Hey there, this is Jake from Pigeon Forge. Thanks for joining me. Today we're going to talk about HashMaps again. Hopefully you watched the last video in which I discussed HashMaps and the whys and hows and compared them to arrays. And I promised a tutorial on using them in a real application. Now, I'm using the term real application a little bit loosely here. This application would be of limited use. But what we're going to do is we're going to build a program that will read a text file of colon-delimited lines in which there is a term and a term definition, and we're going to use it to build a simple quiz for like vocabulary or maybe studying terms for a certification or something like that. So probably in a real world application you would want something with a GUI and make it a little bit more interactive. This will all be text-based, but by using this I'll show you how to import the file, use the multi-tokenizer. You'll be able to take input from the user. We use HashMaps, HashSets. We are also going to use a shuffling algorithm to shuffle the deck and track a user's progress. So let's go ahead and move over to Eclipse and create our project. Okay, from Eclipse we'll go to File, New, Java Project. Let's bring this down so you can see it here. Okay, and the project name we'll call it Term Study, something like that. We're going to use the default location. Leave everything else as is. We're going to take off this module info, hit finish. Okay, so now we have this thing called Term Study. And to start off with, we are going to create three classes. We're going to have the main class, we're going to have a term list class, and we're going to have a term class. And I think that should be enough for the entire program. So let's go ahead and we will first, under source here, we'll create, let's see, new class. And we'll call this class, we'll just call it again Term Study. And package name, Term Study. And let's see, we want to create the public static void main. And let's go ahead and finish, that should be good. Okay, so now we have our main method for Term Study. Let's create another class, new class. We will call it Term. We don't need the public static void main, so hit finish. And we're going to create one more called Term List. Okay, so from Term Study, let me go ahead and let's zoom in here, make sure that you can see this okay. I'm hoping that will show up clearly on your screen. All right, let's start by creating the term class, the object, and defining that. That will be a good starting place, I think, for what we're going to do. We're going to start by, let's create a couple variables. Public string term and public string definition. That's all that we really need for storing the list of terms. But a couple of other things that we're going to want eventually, let's see, initialize a counter for number of times seen. And what this is going to do is as you go through the list, and when you're playing the quiz or going through the quiz, it will count how many times you've seen it. Because what we're going to do is we're actually going to, if you get it correct, we're going to take it off the pile and eventually reshuffle the deck and then go through the ones that you missed the first time. So when you're finished, it will show you, how many times you had to guess in order to get it correct. All right, so let's see, do public int times seen equals 0. And we want to make it public so that it's easier to access from our main class. We're also going to initialize whether or not correct. This isn't going to be the most sophisticated method, but we're going to create a Boolean value for whether or not the user has gotten the term correct. And so we're going to start that as false. And then as they go through the quiz, if they get it correct, it will be marked correct, and it won't show up again when we shuffle the deck the next time. Next, we need to create the class constructor so that when we initialize the object, we can go ahead and create the object passing a couple arguments. So constructor, say term string definition. Say this dot term equals term this dot definition equals definition. Okay. And next I want to go ahead and create the toString method, and what this will do is that when you go to print out the object, this will create the default string text that's going to be printed when that object is called. So let's see, toString should be pretty obvious. Public string toString block return. Let's return the term, which is going to be the actual word, plus let's see, colon, and then we'll add a little quote there. I don't know why I did that. Definition plus close that, and then we'll say times seen plus attempts. Okay. So now when we print out this object, it will return. It'll automatically return this as a string. It'll return the word plus its definition and plus the number of times seen, and it'll create a nice little printout. You'll see that once we get to the actual gameplay. Next, let's create a method. Let's see, public void mark correct. We'll increment the number of times seen, and we will mark correct as true. Oops, forgot the semicolon there. Okay. And one last one, we will do public void mark incorrect times seen plus plus and correct equals false. All right. So now as we go through the quiz, if the user gets the term wrong, it will call each of these methods, or it'll call the mark incorrect method, increment the time seen, but still leave it as false. If they get it correct, it will mark it as true and still increment it. So, and then we'll go through, and when we shuffle the deck, we'll take out all of those that have been marked true so that the user doesn't see that again, because they've obviously mastered that. I think that's actually everything that we are going to need for this class. So we can go ahead and save that. Now let's move over to term list. The term list is going to be a list of all the terms that we've created. So it's going to be an object that contains a bunch of objects. In order to hold those objects, this is where I want to use a hash map. We can do this in other ways, but this is a way for us to be able to use hash maps and get some practical application of that. So let's create a hash map for storing items. Okay. All right, so we're going to declare public. We want it public so that we can access it. String terms equals new hash map. Okay. Now you notice that the hash map has a red underline, and that's because we haven't imported that module yet from Java Utils. So we can just hover over and click import hash map Java Utils, and it goes ahead and imports that module for us. All right. It's a quick recap on hash maps. When you initialize them, you need to declare the data type for the key and the data type for the value. In this case, we're declaring a string as the key, and we're declaring an object as the value. All right, and let's see, next, let's go ahead and create a constructor. And term list string file name. We're going to take in a file name as a string, and we'll use that. We'll go ahead and do all of the file reading within this constructor. Probably not the most efficient. It's definitely not, good modularization, but you'll get the point. And we could always go back and refactor it into something a little bit cleaner, a little bit more efficient later. But the goal is to, again, focus on hash maps. So let's create a scanner for reading the file. Scanner. And we are going to need to import scanner. So that's why it's red. So we import scanner. Now scanner's been imported. Okay. Let's now I'm going to read the whole file, and we're going to hold it as like a raw string content. and then we're going to tokenize it later. So you'll see that they're like warning. It's not red, it's actually yellow underlining these. It's because we haven't used them yet. If you haven't used Eclipse, one thing that's really nice about Eclipse is it lets you know whether or not you've actually used that variable somewhere else, so you can get rid of excess code if you later decide that you're not actually using it. All right, so we got that string. Now let's go ahead and open file and import terms. Okay, I like to, since we're going to have interaction with a user, I want to print out some status messages. Print line attempting to open terms list, and we'll then go ahead and include file name there. That way, if there's some sort of error, they know where they were at. All right, so what do we do to open a file? So we're going to do scanner equals new scanner, and new file name, and then we want to set a delimiter. This is going to be the delimiter for how the scanner determines what actually gets scanned, if it's a whole document or if it's scanning line by line. We're going to use scanner.use delimiter, and we're going to say //z, and that will just basically read the whole file in as one big string of text. And okay, next we are going to actually scan the file, and we're going to say content equals scanner.next. Now remember, we said that the delimiter is the //z, so when we say .next, it basically imports the whole file. And we say system.out.print line file successfully read. Okay. And we're going to need to close the scanner. And we say scanner.close. All right. Now we aren't okay. So now if you see, if you look at the file here under scanner, it's got an underline here for files because we haven't imported files. So we click file, we import that module. Now what it does is it gives us an error for the entire line, and that's because whenever we're importing a file or trying to read a file, we really need to use a try-catch block. Eclipse will kind of handle this for us. So we're going to select surround with try-catch, and we actually need to take this code here and put it under in the try block. So now what we have is we have this try block, and it's going to try to open and scan the file. And if everything goes successfully, then it'll import the file, it'll close it, and everything's good. If it can't find the file, then it will throw an exception, which is going to throw it to the stack trace. All right. So we have imported the file, and what we have is we have one long string. We need to do something with that string, and I'll show you how the file set up. I'll show you how the file set up in it. Before we actually go through and do the tokenize, let me show you what a file would look like that is prepared to be imported as a terms list. We will create a new, let's see, and to save us some time, I'm actually going to create it up in this root directory here. File new text file, untitled text file. And we're going to, we're using a colon-delimited. Let's pretend that we're studying terms for the Security Plus test. Let's do, say, mttf colon mean time to failure, mean mttr mean time to repair, mtbf mean time between failures, mtbsi mean time between service incidents. And we could go on and on, creating hundreds and hundreds of lines of terms that would be helpful for us to study for our Security Plus examination. Let's go ahead and save this. Save as. We're going to save it within the term study, and we're going to call it terms.txt. Okay. So remember, terms.txt is going to be the file that we're going to import. So this is what the file would look like. It's just a simple text file. Again, term with a colon delimiter and then the quote definition or breakout of the acronym. All right, so now we can go back to terms list. Now you know what we're importing. So if all goes well, it's going to import all of that as one solid chunk of text, but we need to break that up, and we're going to tokenize that. Okay, so in order to tokenize that, see tokenize the terms. We're going to basically split those into lines, and we're going to split the lines into terms and definitions. System.out.print line tokenizing. Again, just some sort of feedback to the user. String tokenizer, multi-tokenizer, new string. Okay, so don't worry too much about the tokenizer. That's a different topic for a different day, but basically it's going to go through. We've specified that we want to use the multi-tokenizer, and we've also specified what the raw string is, which is content here, and we specified the delimiter, which is a carriage return. So at the end of the line, go ahead and split each line and create, make each of those a token. Okay, and let's create a token. We haven't actually done anything yet with the tokenizer. We need somewhere to hold it, so we're going to say string token. So each line is going to be thrown into this string. All right, and then, oops, I did the wrong slashes there. There we go. Okay, and we're going to loop through the multi-tokenizer. Okay, so we're going to use a while statement here, so that when the multi-tokenizer is basically run out of tokens, that it no longer loops. So we're going to say while multi-tokenizer dot has more tokens, and oops, well, it has more tokens. We want to grab the token. We're going to say token equals multi-tokenizer dot next token. Okay, so now it's going to throw that next token into the token string, and we're going to work on that string. And how we're going to do that is we are going to create a very small array, just a 2-item array, and we're going to do that by string array, term array. You can call this whatever you want. We're just using it here locally. It's not going to be used again after this method, after this constructor. And we're going to do tokens.split, and we're going to split it based on that colon. All right, so what we've done is we've taken that token, which equates to one line, and we're splitting it essentially in two. We're splitting it in term and definition into this string. So in theory, we should have a string of length, or we should have an array, a string array of length 2, with 0 index being the term and 1 index being the definition. Okay. But you may have a file that maybe has some blank lines, and so you have to be careful. So we're going to use if term array.length is greater than, if it's greater than or equal to 2. So we want to ensure that it has at least 2. If it's got more than 2, then we can probably ignore the rest of it. Somebody set something up improperly in the file. But this way we can ensure that there are items so we don't get some sort of index error. Okay. So now we're going to initialize a new term object. Remember, we created the term class. So we're going to create a new term. So say term, new term. Again, the new term is just going to be used here locally, so we don't have to worry about really what we name it. New term. And based on our constructor, we need to put in a string that represents the term and a string that represents the definition. So we are going to say term array 0 and term array 1. That should then create a new object for each of these terms and definitions. One thing that I want to do here, though, is we don't know if there's going to be white space. We probably know there is going to be white space. If you put a colon and you have a space after it just to make it look pretty in the text file, you want to strip that off. So if we do .trim, it's an array, so it's going, or sorry, it's a string, so it's going to trim it for us. It knows that it's a string. Okay, and then the next thing we want to do is let's add the term to the hash map. All right. If you recall, we created the hash map up above, and that's the terms list. And we're going to use that as a variable within the terms list class. Sorry, we're going to use that as a variable within the term list class to store references to those objects. And we're going to use the term as a string, and that's what we're going to use as the key. And we're going to use the object itself as the value. So we say terms.put new term dot term, and then we're going to say new term, and we're just say new term. Okay. So what we're doing here is we're putting the new term's term, which is a string, in as the index. Sorry, what we're doing is we're putting the new term's term, which is a string, in as the key for the hash map, and we're putting the new term itself, the whole object, in as its value. And that should be good there. And I think that at that point everything should be working. So let's now print out a status message, system.out.println, and we say terms.size. The size method on a hash map will give you basically the length of it, and we're going to say plus terms have been ingested. Okay, so I think that that's good. And the last thing that I want to do for this class is let's go ahead and declare toString and say public string toString, and we'll say return term list, and then we say plus terms. Now what this is going to do, and this is kind of cool, is that it's going to print out the hash map, but because we've declared what the terms should look like individually, how they should be represented in a string format, it's going to format it for us kind of nicely. If we didn't actually declare the toString method within the term class, it would print it out as an object, but we don't want to print it out as an object because there's like gobbledygook and references and things that we don't care to see. That's not appropriate for display. Instead, it's going to print out a nicely formatted message. Okay, so I think that now we're done with the term list. Oh, we've got an error somewhere though. Let's see, tokenizer. Oh, okay. So what I did was I need to actually, in the catch block here, I need to go ahead and, I'm sorry, it took me a second there to, okay, so we need to go ahead and say that content equals that. That's going to give us then a null string for, or an empty string for content, so that the multi-tokenizer does not choke. That was my bad. All right. So now we've got the content as a empty string if there was an error with the file, and it's just going to return a no terms list, and then the rest of the program should run fine. Now we can save it, and now we can move along. All right. So let's go back to term study. And this is empty. We haven't created any of the program logic yet. Let's start off by, let's go ahead and initialize. Oops, let's get rid of this to-do statement here. Let's initialize the terms list. And get rid of this. I say term list equals new term list terms.txt. If you wanted to make this more flexible, you could ask the user for input and have the user type in the name of the text file. But here we're just going to hard code it for the sake of this tutorial. We could probably run this at this point and see what we get as far as output. Let's go ahead and run it. Okay, so if you look down here at the bottom, we have our feedback messages: attempting to open terms list terms.txt, file successfully read, tokenizing for terms have been ingested. So now we know that we have been able to read the file, tokenize it, and store it into this terms list. Let's go ahead and do system.out.println, and we'll print the term list and see what that looks like. All right, and as I'd mentioned, because of the way that we formatted the toString method for each of these, it now prints it out as a sort of pretty a list. The hash map gets represented as the key, which is mttr, and then it shows us what the actual entry is, what the object is for the term. And again, we'd formatted to show the the term, the definition, and the number of attempts that have been made throughout the quiz. So that's handy. Let's go ahead and comment that out though for now. Okay. Now, at this point, we can actually start the game. So let's go ahead and initialize new scanner for user input. Because the guessing game is going to require the user to input something, we want to initialize that scanner. So scanner. Okay, and we're going, oops. We're going to have to declare scanner in here as well. Hover over it and import it. So we've imported the scanner module. Okay. Let's now, we're now going to create a hash set. We've used a hash map, but now we're also going to use a hash set. A hash set is not something that I covered in the last video, but a hash set is, it's similar to a hash map, but it doesn't have key value pairs. It simply has, it's simply essentially like an unordered list of objects or strings or primitives or what have you. And a set, for those that don't know, a set is something that it only contains unique values. So if you tried to put 1, 1, 2, 2 into a set, the set would be 1, 2. So it basically removes duplicates, which is going to be handy for what we're doing here. So we're going to say hash set. Okay, so we're going to do hash set. And just like with HashMap, we have to state what the data type is. And the data type here is going to be a string. We're going to say, oops, new hash set. I'm missing something here. I forgot to add in the actual variable name. We're going to call it quiz list. There we go. And we're going to import the hash set utility. Now we're going to iterate to populate quiz list. And you'll see why we're doing this when we get down a little bit further. We're going to do for string key term list dot terms dot key set. And we're going to do a block. All right, what we're using here is a for each loop, and we're going to be looping through the term list dot terms, and the term list dot terms, if you remember, is a hash map. So what we're doing is we're actually iterating over that hash map to retrieve the keys. That's what key set is for. So we're saying that string key. So for each key, we're declaring that the name of the string. We're going to get the key string out of the terms hash map. Say if term list dot terms dot get key correct quizlet quiz list dot add key. All right, we're going to get the key that we've retrieved from the list of keys, and we're going to check to see if it's been marked as correct. If it's not marked as correct, so if it's false, we want to go ahead and add it to our list, because we only want to generate this list based on the terms that we have not gotten correct yet. We don't want to have to continually go over those that have already been marked correct. So we're only adding those terms that haven't been marked correct yet. Now the first time you go through this program, when you initialize the quiz, all the terms in theory should be put in as incorrect. They haven't been tested yet, so they can't be correct. But once we go through like one round, perhaps you got 3 of the 4 terms correct. Those terms are going to be taken out, and then it's going to basically return just one item in the next list. Okay, so that's going to create that. Okay, if blah blah blah, that should be, that's our for loop. If statement. Okay, we should be good there. Now let's print out a couple systems messages. System.out.print. Initializing quiz. Here, let's go ahead and do the quiz list dot size. Remember, the quiz list is a hash set, so this size is going to tell us how many items are in it. And item to be quizzed. That's going to let the user know how many items he or she will be presented with. And system.out.print line. Let's roll. And that will prepare the user to be quizzed. Okay, so we could probably go ahead and run this and see where we're at now. You'll see that it has done everything we've seen before, except now it says initializing quiz, 4 items to be quizzed. So it pulled those 4 items that are still marked as false for their correct value, and it's put them into a list, and now it's telling the user be prepared to be quizzed. Say while quiz list dot size is greater than 0, basically saying if there are items in the quiz list, remember we're going to be removing the items that have been marked as correct. So long as it's still got items in it, keep the quiz going. But before we do that, let's int round equals 1. Let's go ahead and create a variable that's an integer, and that's going to keep track of the number of rounds that the user's gone through. All right, so we're gonna do a while loop, and say system.out.print line. Say round number plus round plus, and okay. That should let the user know how many rounds they've gone through. Now, if you've got just a short list, it's probably not going to take long to get through it. But if you've got a long list of 130 terms, it's possible it may take the user many rounds to get through all of them in order to get them all correct. All right. Now, let's see. Let's convert the list to an array. I want to push that list into an array so that we can keep track of the order. Now, HashSets, HashMaps are not ordered. They just appear in whatever order the program is tracking them. But if we cast it to an array, then we have the sequential order, and we can randomize it and keep track of that so that they're not constantly being shown in the same order. So we're gonna cast it to an array. Okay, so to cast to the array, we're going to declare a string array. We're gonna call it term array. Equals quiz list. ToArray. There's a ToArray method, and in that ToArray method we're going to say new string quiz list dot size, and I think that should be good. All right, so what we're doing is we're declaring a string array, and we're calling it term array, and we're using the method for the hash set, which is ToArray, and we're declaring a new string array of this size. So when you put it in these square brackets, that's declaring the size of the array. And so we want to go ahead and make sure that the array is of that size. So it's going to create that array to hold these items, and it's going to automatically throw all of those items into there. So that should create the array. Okay, next we're going to randomize the array in order to keep things fresh. And system.out.print line shuffling plus term array dot length plus quiz terms. That's going to again provide some more feedback to the user, letting them know that the array is being shuffled. Where did I get this extra? I don't know where I got that from. But in order to shuffle, we are going to let me go ahead and I'm going to create a method below called randomize, and we're going to throw the term array into that. But we haven't created that method yet. So let's go down. Let's go ahead and create that array. Let's go ahead and create that method for randomize. So we're going to say static void randomize. Say string array input array. All right. What's it giving? Why is it giving me this? Oops, I didn't go down far enough. Let's go down here. There we go. All right, I didn't put that down far enough. We're going to use something called the Fisher-Yates algorithm, and what that does is it takes the array and it shuffles it. It starts at the end of the array and works its way back, creating random numbers, taking that last item and putting it into a different random slot, and it's constantly swapping values. It may not be the best, but it tends to be one of the most popular ways of shuffling, and it's good enough for this tutorial. So let's generate random seed. So random RD current. It's basically going to look at the current thread and it's going to create a random seed from that thread. And then we're going to loop through input array in reverse. Let me scroll down here. We're going to loop through the input array in reverse. I'm going to do for int I equals input array dot length -1. Sorry, yeah, -1. And then I is greater than 0. I minus minus, and we're going to decrement there at the end. And we're working backwards. Sorry, wrong block. There we go. Okay, so we're going to grab the next random integer range 0 to I plus 1. So it's inclusive from I, exclusive up to the index plus 1. All right, and int index equals rnd.next int I plus 1. So that's going to get us the next random integer. And again, you set the range here. So the range, it automatically starts at 0 to whatever you have in parentheses as exclusive. That's why we do I plus 1. Let's see, temporarily store string at index. We're going to say string Okay, so we're going to create this string as a temporary hold, as a temporary storage place. And then we're going to swap index I into index index. And we're going to say input array index equals input array I. And now we're putting that, we're taking the string from the input array I and putting it into the index, which is where we took the string out of as a temporary placeholder. Now place temp string into index I. Put array I equals A. So what we've essentially done here is we've looped through the array backwards, randomly generating new indices into which we're going to put the current index item. And this is going to create basically a shuffle for us. So now that we've created that method, if we go up, oops, we have to import random. Let's import random util. Okay, we should be good. Now we now have we can make the call to the randomize method and put our term array into it. Okay, now let's loop through the items for int I. Array.length I plus plus. All right. Grab the current term, string term key equals term array I. Remember, we shuffled this, so now what we're going to do is we loop through this array, which has been shuffled. We're going to grab the object that the item represents. So we got the string. Well, actually, we haven't gotten the object yet. We're just getting the string for it. And now we're going to grab term object. And say term current term equals term list terms dot get, and we say term key. Thank you. And now we're going to go ahead and get the user. We're going to create a user prompt. Say system dot out dot print line what term is defined as, and we'll say plus current term dot definition plus question mark, and in that, sorry, I'm going off the screen here a little bit. Okay, so that should create a user prompt. Not sure if you're able to see this. A user prompt, and it's going to grab the definition from that current term that we have pulled out as an object. And it's going to display that definition, and the user is going to be expected to put in the actual term. So let's get the user response. User response. We're going to do string response equals scanner dot next. That will get whatever they put in and whatever they type in, and they press enter, and it's going to get us that string. And compare it, user response to the term. Say if response, go ahead and say to lowercase, because just in case they're putting it in all caps or they make a mistake in the capital letters versus lowercase letters, we don't want to ding them for that. Say dot equals current term dot term dot to lowercase, and that's going to put that term in lowercase as well, because we've actually stored it. We probably stored it in all caps, or who knows, any combination thereof. So we want to reduce both to a lowercase and compare it. We have to make sure that when we're comparing the strings, we're actually using the equals method against the string. If we were to use the double equal sign here, it's actually going to compare the object. We don't want to compare the object, because if we compare the object, we're actually comparing to the object that's resting in memory, not the actual string value. If it equals that, that means it's correct, so we mark it as correct. Say current term dot mark correct, and we say system dot out dot print line correct. And then we're going to, because they got it correct, we're going to remove item. Just quiz list. Remove term key. It's going to remove it. Else, scroll down here a little bit. Else, which means it was incorrect. Current term dot mark incorrect. And then system dot out dot print line incorrect. And make a sad face. And in that. Okay. That's going to loop through. Let's go ahead, and at this point I think we can actually increment round, plus plus. That is going to now loop through until all items have been properly identified. And I need to semicolon there. If they actually break out of that while loop, that means that the game is over. So we can print game results system.out.println. You have correctly identified all terms. And we will then do, let's do one last thing, and this is going to be, oops, we're going to iterate over terms list to show attempts. For term terms list, oops, term list dot terms dot values. We're iterating over the values of that hash map now. We're going to do system.out.println term. Remember, we created that nicely formatted string for each term, and that's going to print that out. And now we need to do scanner.close. We need to be sure to close the scanner. And I think we're good. So let's go ahead and run this now. Let's see what happens when we run this. Oops, we've got an error somewhere. So let's see where we've got an error. Okay, so what I did was I accidentally put several of these lines of code within the wrong block. And that's one of the challenges of doing this coding here and having everything zoomed in. So I'm going to zoom out a little bit here. I hope that you can see this, but I actually have the incrementing of round one level too deep, and I have this part one level too deep. So I'm going to take that out, put that down here, and when the scanner.close, that's going to actually be end of game. And the incrementing of the round, was one level too deep, so we're going to put that down here. I'm going to zoom out a little bit more and increase this a little bit here. And you can see here, I had the increment round within this for loop, but this for loop is actually going within one round. So what it was actually doing is actually incrementing every time we got to a new word. And this end of game was actually within this while statement, within this while loop, and that was causing other errors as well. So now that it's properly set up, let me zoom back in here. Let's go ahead and try to run it again. Okay, so mttf, oops, incorrect, mtbf, mttr, dog, mtbsi, mttf. You see that we got to round 2 now, and it's shuffling 2 quiz terms, so mttf. Yep, that's correct. All right, so we then have the final readout here saying you've correctly identified all terms, and then it goes through the list telling us how many attempts it took us to get each of these correct, and that's the end of the game. In a future episode, I plan to refactor this a little bit. I plan to actually incorporate all of the Security Plus terms into this. We will implement some multiple choice questions, maybe some an option to be tested on actually defining each term, and then have some sort of percentage of accuracy. So sometimes it's going to be hard to type the whole term. And yeah, so be on the lookout for that. Okay, I think that's enough for today. I hope that you found this a little bit useful. Pardon some of my errors and typos along the way. If you have any questions about HashMaps, please do feel free to ask them in the comments below, or if you want to call out mistakes that I made, add those to the comments below, or if you have other ideas on how to make this tutorial or future tutorials better, please add them to the comments below. Hope to see you again soon. Bye-bye.